Okay, so we'll continue on in our coverage of dplyr. We left off on Monday talking about kind of some of the basic functions of select, filter, and mutate. Select allows you to select columns. Filter allows you to select rows based on criteria. Mutate allows you to create new columns. And when you create new columns with mutate, you want to make sure you use a window function, which basically takes in a vector of values and returns a vector of values. So whether you are kind of doing operations on two vectors of values, doing vector-wise operations, that's fine. Or if you're going to do some kind of summation, you've got to do like a cumulative sum or a cumulative mean or something of that sort. On the other hand, we have the function summarize. Summary functions, like summary statistics, take a bunch of values and return one value. So for example, if you had a sample of data and we ask for the mean, that takes a bunch of numbers and it boils it down to one number. I mean, that is the point of a summary function, is that it provides a summary. So it gives you one value, so you have less to look at than the whole thing, right? So, like your GPA, it's a summary function of your academic performance. Rather than looking at everyone's individual grades, it boils it down to one value. That's what these summary functions do. So the median is a summary function. You can give it 6 values and it will return the median of those 6 values. Or you can ask for the variance and it would look at that, okay? And so in this case, in order to use the summarize function, you would take our original data set and you'd say, I want you to create a summary, all right? You'd say summarize, and then you give it arguments. These arguments are going to be the names of the columns in the resulting table, right? So it's going to output a tibble, and in this case, our table will have 2 columns, and so we need to give it names of those columns. So we're going to say we want the column median and we want the column variance. There's no inherent meaning to the names I give it. If I want to call this middle value and call this squared deviation or average squared deviation or something like that, we could say that, right? These are just names. There's no inherent meaning, but we do have to provide it a formula or a way to calculate the value that we want there. In this case, we want to calculate the median of the column amount. So we would say median parentheses amount. Over here, we want the variance of the column amount. So we would say variance parentheses amount. Now, this seems like a lot of work, additional work, just to get this thing. Because at this point, if I asked you to get the median of these 6 values, you would probably just write pollution $amount, and you'd put the median around that function. You'd say median pollution $amount, and that would spit out 22.5. And then you'd say variance pollution $amount, and that would spit out 1731. But here we're writing, take the data set pollution, throw it into the function summarize. We're going to create columns with these names, and the way the column will be calculated is this formula. Okay, so these are just examples of calculating the median and the variance. Here's some examples of calculating the mean of the column value, or the sum, or even just how many rows are being summarized here. So here we're saying, how many values are being summarized. There's 6 values that are being summarized. So that's just the function n with a parenthesis. So it's kind of like a count, how many values are there. But again, we could just do mean pollution $amount, sum of pollution $amount. And there's no n function in R, but what would we do if we wanted to know how many values are in pollution $amount? Length, right? We would do length, pollution $amount, and it would say how many values are in that vector, right? So in this case, because pollution $ amount would simplify to a vector of 6 values, and we would say length, and they would say six values there. Okay, so that's summarize, and at this point, the summary function, the function summarize, seems like a lot more work than it's worth. And right now, that's true. We will come back and we'll look at this, and it will make our lives better, I promise, okay? So again, summary functions, you take a vector of values and it returns a single value. So things like the mean, the median, the sum, standard deviation, variance, those are all summary functions. We can also do things like n for the number of values in the vector, but you could also ask for first, last, or the nth, and these are all functions that dplyr provides. Okay, so here's just a picture of taking a vector of values and returning one value. Okay, before we get into really the power of summary, here's just a few examples here and of dplyr usage. So here is arrange. Arrange allows you to sort the data. So we would say, you know, we want to take our data set storms and we want to arrange them by wind speed, right? So if I take this and I say arrange on wind speed, it's going to output a table where it's sorted based on wind speed, and in this case it's sorted from smallest to greatest. So this is as illustrated with colors. On the other hand, if you wanted it to be sorted from greatest to least, that's easy. We would do arrange storms descending on wind, okay? And or you would say storms piped into arrange descend wind. Okay. You can also give it multiple variables. So here we have two storms, Alex and Arthur, that have the same wind speed. So they are tied. And so when dplyr does this, it's going to, in general, it will leave it in the order that it appeared in the original data set. So it's got Alex, and then Alex appeared before Arthur in the original data set. So that's kind of why Alex appears before Arthur after we apply arrange to it. But if we wanted to break a tie, we could give it another variable, and in this case, we give it the variable date, and it will look at the date column and use that to break ties. So these both have 45. Here, Alex appeared in 98, and Arthur appeared in 96. And so here, if we arrange it based on wind, then date, it would put Arthur at 96 before Alex in 98. Okay. I think we've already talked about the pipe operator, so I think we can kind of skip over this stuff. So instead of doing select storms, we just pipe storms into select, and so on and so forth. And you can string together pipes, right? So we take storms, we throw it into filter to select the winds, and then from there we pipe it into select to select the columns that we want, and this is our resulting thing, okay? With storms, we're going to mutate it to create another column, and then we use the function select to say which columns we want to end up selecting, and so we get storm and ratio, and this is our resulting data set after these pipes. And this is the shortcut, so you don't have to type in % greater than %, but you could just say Command Shift M or Control Shift M, and it inserts pipes. Okay, unit of analysis. So this is where the function summarize really comes in handy. So if we took our data set, this is our pollution data set, and we fed it into summarize with mean, sum, and n, this is what we would end up getting, right? So if I take a look at our pollution data set, I can say pollution, and I want to pipe this into summarize, and the resulting columns I want, we can, you know, it can be anything. I can call it average, which is going to be the mean of the amount column, and we're going to have the sum, which is going to be the sum of the amount column, and n, which is going to be the number of rows being summarized, and there we go, average, sum, and n. This is what we end up having. maybe just for consistency, I'll call it mean. But that's it. It took this column amount and it calculated the mean, the summary, and the n. But again, you might just say, well, why don't I just do mean of pollution $ amount? And yes, that would work just as equally well. But this is what we have so far, right? So we apply the summarize function. It takes these 6 rows and it produces the summary values that I've requested of it, okay? We might look at our data set and we say, hey, you know what? I don't want to boil all 6 values down into one. Instead, I want to establish groups, all right? If I look at my data set and I look at the column city, we see we've got 3 cities. We've got New York, London, and Beijing, and I want to establish these as groups, and I want summaries based on these things. So I want the mean value for the mean of the values associated with New York. I want the mean of the values associated with London. I want the mean of the values associated with Beijing. This is where we use the group by function. We would tell dplyr that in our data, we want it to group by the city, okay? And dplyr will look through the city column. It will recognize that there are 3 unique values, and it will establish 3 groups. And then when we ask it to summarize, it will create a row for each group that it has recognized. So it recognizes there's a group for New York, London, and Beijing, and it produces summary values for each of those groups. Okay? So to use the group by function, all you do is you take your data set, in this case pollution, and then you just pipe it into the function group by. Group by, and in this case we want to group by city. So there's my original data set. When I pipe it into group by, it doesn't look like much has changed. The output of pollution and pollution grouped by city, these pretty much look exactly the same. The only difference really is this line that says groups. It's grouped by city, the variable city, and there are 3 resulting groups. This is kind of our only indication that groups exist, okay? So the difference between the original data set and the grouped by data set, when we just print it out, doesn't look like much. But this makes all the difference here, okay? So keep in mind, earlier I said we want pollution, and we piped it into the summary function. We have summarize with mean, sum, and n, right? So when we did this, it took all 6 rows and it compressed it down into 1 row, okay? Basically, what I can do now is I can do pollution, and then if I throw this into group by city, before I pipe it into the summarize function. So this command is exactly the same as the command, whoops, hit the wrong key here. It's the exact same command as I had before, except the only difference is I'm piping it into group by before I pipe it into summarize. Okay, and now when I do this, by having pollution grouped by city, R then recognizes, oh, you have 3 groups, and so I will run those summary functions on each of those 3 groups. And so it says, okay, because you asked to group by city, I've recognized there is New York, London, and Beijing. Those are the 3 unique values I see in the city column, and I'm going to create summary values for each of those things. So, okay, so here we grouped by city, and then when we combine group by with the same summary function, it splits up the data into those 3 groups, and it creates a summary for each of those 3 groups, and it merges them back together, okay? Which is nice for us, okay? If instead, so this is pollution grouped by city and then summarized. It recognizes 3 groups for city, and it summarizes that. We could group it by size, and it would recognize that there are 2 groups. So I could take the same thing, pollution, and I would say group by size. So again, this is our original data set, 6 rows. If I group by size, it's going to just see large and small as my 2 sizes. And so our resulting output will just have 2 rows. 1 row for large, 1 row for small. And this is what we have here. Okay, and it does the same thing. It calculates the mean, the sum, and n, how many rows are being summarized. So for this one, New York has an n of 2 because there were 2 rows that had n. Over here, large has 3 because there are 3 rows that had large established in there. Is that okay? Yes?
Can you group by more than one column?
Yes, you can group by more than one column. So in this case, well, you have to group by a categorical variable, okay? So in this case, we've got the column city and the column size. And there's 3 groups in city and 2 groups in size. So if I group by both city and size, I would end up having 6 groups. And so if I throw that into summary, so if I group by city and then size, we pretty much get the exact same data as we originally had here, okay? Except group by also kind of establishes some sorting rules. So it's going to sort by city and then sort by size. And the default is alphabetical. So it's going to put in, you know, Beijing, which starts with a B, then London, and then New York. And in that case, and then it goes large, small, because large starts with an L and small starts with an S. Okay, so it's pretty much, you know, when we group by two things, it will establish 6 groups, which is fine, but it doesn't really help our cause in this example. Okay, but we've got another example here where it doesn't. Okay, there is a function called ungroup, which you know, let's say you're dealing with something and you've created groups and you've summarized based on that, but then you want to summarize based on different groupings, but like, I don't know, maybe you overwrote your original data set and so these groups information exists. You'd want to, you can clear out the groups by using ungroup, right? So here I have pollution. If I say pollution 2 is going to be pollution group by city, okay? So pollution 2 we can see is groups city, and then if I take this and then I say, oh, you know what? I want to not. I want to group by size. Okay. Oh, I guess it got rid of the things, but I was thinking it just added onto the groups. I guess it did something different from what I expected. This is fine, but there might be a time where you want to use the ungroup function, and this will do it. Okay. All right. So here is there's a data set called TB. This is like just a little subset of it, but the original TB data set for tuberculosis cases has a lot of rows, 3,800 rows. But let's, for example, we're just going to look at 3 countries, Afghanistan, Brazil, and China, in the years 99 and 2000. We've got sex, female and male, and cases. It looks like we just made up some numbers here. Let me just kind of show you how this can be done. With dplyr, what would I do? I would do dplyr TB, and I would filter what? Country has to be in the set Afghanistan or Brazil or China. Okay. And I want a year to be in the set 1999 or 2000. Okay. Oh, country is in lowercase. That will do it. Okay, and so here now I've got 12 rows, Afghanistan, Brazil, China. Let's create a column called cases. and this will just be the sum of the columns child, adult, and elderly. Okay, so here, that is not correct. What did I do? Oh. Okay, see, it's child plus adult, because you have to think, you need window functions, right? So you have to, sum is not vector by vector addition, right? So sum, like if I take in vector values and I throw it into the function sum, it will boil everything down to a single value. What I want is I want child plus adult plus elderly. This does element-wise addition, right? And so this is what I want, okay? And so this actually works. If I did child plus adult plus elderly, then I get cases, and then we will feed this into select, and we want to get rid of. So we want country through sex and cases. Okay, so there we go. So this is kind of what we have, and we'll call this, we'll take this output and we'll call it TB2. Okay, so TB2, we've got 12 by 4 table, country, year, sex, and cases. Is that okay? What I did with the dplyr? Okay, and so, well, they just have cases 1, 2, and 3. That's not correct, but all right, so we can establish groups by multiple columns. And so we're going to group by country and then by year. And so how many groups will this establish? If I say I'm going to group by country and then group by year. So I'm going to take my table, TB2, and we're going to group by country and then by year. How many resulting groups will I have? Okay, so it's going to look at how many unique values of country I have. I've got 3. And then how many unique years I have. I've got 2. And then, well, and it's going to just kind of see how many unique pairings I have. It's going to see we have a total of 6 years. Well, if we group by country and year. Okay. Now, if there were only, if for whatever reason Brazil 2000 did not exist, then it would establish only five groups or something. Okay. So here we've grouped by country and year, and then if I throw that into summarize, where I add those values up, we will end up getting six rows. Okay, so I would throw this into the function summarize, where I would do call it cases, which will be the sum of the cases column. Right. So here in Afghanistan in the year 99, we had 745 cases, and in the year 2000, 2,666, and so on, and it's just basically adding these 2 rows together, okay? Each pair of rows. These numbers are very interesting. I have no idea. I don't know anything about this. This is tuberculosis, but in China there are far more cases. China and Brazil, more cases of males having tuberculosis than females. And in Afghanistan it's the opposite. I have no idea. Okay. If I take these results, okay, here I've got six rows here, okay? And I throw that further into summarize, where cases is equal to the sum of the cases, okay? Right here, it established that there were 6 groups, okay? And here, now it recognizes that, okay, we got 6 rows. I can take this result and I can pipe that further into summarize, okay? And we'll call the new column cases, and this is going to be sum of the cases column. And it will return only 3 rows, 1 for Afghanistan, 1 for Brazil, and 1 for China, okay? So it's taking, so here we had 12 rows that were ungrouped. we grouped them into 6 groups, and when we summarized that, each group, those 6 values, each had their own row. Okay, if we summarize it further, because we've established by country, then by year, it will then summarize based on country. So the only, if I go back and I use the exact same command that I did last time, except I switch group by year and then country, what will this do? Yeah. Yeah, so how many rows would I end up in my resulting table? 2. Exactly. Okay, I would get a row for 99 and a row for 2000. If we looked at the intermediary table, the table before, so here, again, to get 2 rows, I had TB, group by, and then summarize, right? I ran 2 summary functions in a row. If I didn't do that, and I just did group by and then summarize, like I did back here, group by country, year, and then summarize, we get 6 rows. And here we get 6 rows, and it's the exact same information. The only difference is that first it's sorted by country and then by year here. Over here it's sorted by year and then by country. But if we look at the data, Afghanistan 99 had 745 cases. Afghanistan 2000 had 2,666, and we see that 2000 Afghanistan had 2,666. So the same data is there, it's just arranged a little bit differently, and it's arranged by the order that we've established in group by. So group by kind of establishes a default arrangement for these summary tables. Okay, and so dplyr really makes this stuff a lot easier in terms of taking our data, our non-aggregated data, and then allowing us to combine them. We'll first separate them by groups, summarize those, and then bringing those back together. Okay? If we didn't have this, how would we have to do this in base R? It's a lot more painful, okay? We could use, there's tapply, okay? And tapply would take our, kind of our vector, and then index is kind of a list of 1 or more factors. So here, I can try to do this by, like if I wanted to get this result, Afghanistan has 3411, Brazil has 118,000. I can do tapply, and I would take TB2, and I would say the index will use TB2 $country. I'm sorry, I want TB2 cases, TB2 country, and the function is equal to sum. And I think this would do it, okay? If I tried to do it based on country and year, I think I would have to do paste TB2 country, TB2 $year. And would that work? It does, okay? Except this is now, you know, I mean, the arrangement of this is a little bit messy, and I had to artificially create a thing by pasting country and year together to establish this, and I lose the ability to then summarize this further. There's also the aggregate function. And how would I do this? I would do aggregate. Okay, so I would do aggregate cases by country, data equals TB2, and the function is equal to sum. Okay, so that's this one. All right, can I do country and factor year. Okay, so this will do this. So so it's possible to do it in base R, but what's happening here, I think, is less intuitive than to say, take your data set TB2, throw it into the function group by to establish groups, country and year, and then create summarize by summing up the cases column. Okay, I don't know. In my opinion, the command here is much easier to understand and remember than trying to remember R's base R functions. Okay, so but it is possible to do it in base R. Okay, just but it does make our life easier here. Okay, let's see. Okay, so here's, again, we had 12 rows. We can group them by, country and year, and then we would have 6 groups. And then if we summarize that further, then it would return 3 rows for the country. And then if I further summarized that, then it would add everything together and just return 1, right? If we had no groups and we did summarize, then it would just return the sum of everything together. So this is what we have with dplyr. Recap, we can do select and filter, we can arrange, we can mutate, and we can make groups by with group by and summarize, okay, which makes our life a lot easier. There is I've posted a link on CCLE, which I encourage you to check out. This shows you how things would have been done using base R. So if you wanted to filter rows in base R, it was possible using square bracket subsetting, and you would say, the rows I want to select, and you would put in your logical statements before the comma to select which rows, and it would select those rows. With dplyr, it's easier to do that. Same thing with creating new columns. Dplyr makes that a lot easier. And then as far as aggregation, we showed you it's possible to do the function aggregate, okay? And then and we didn't even show you what would you do if you had multiple columns or multiple summary values to create. With base R, you would use that aggregate function, and then you would have to use the merge function to combine those summary values to get their own thing, which is, again, it's possible in base R, but it's a lot more work. Okay, and then so it's a good blog entry to check out, written by Tony Fischetti here. Okay. Okay, and then lastly, I'll just kind of fly through this stuff on joining data. These are similar to kind of set data. The set functions that exist in R, but they're kind of extended for tables rather than vectors, right? So in R, we do have functions where you can take the union of 1 through 5 and 3 through 8. Oops. And it will take what's there, or the intersection. So this is for vectors, okay, and it will tell you what's overlapping them. But dplyr extends this into kind of tables. Okay, so first of all, there's bind columns, which just kind of sticks data sets together, and bind rows, again, it just binds them row wise. Okay, Y and Z. Union basically extends the union functionality into to apply for data frames as well as data frames beyond just vectors only. And intersect does exactly what you would expect it to do as well, right? So if you got A, B, C, and B, C, D, it takes the intersection of those two by giving you the rows B and C, right? And then set difference will be, I don't think this is quite right. I think it's gonna, I think this just gives you A. Let me just check. So if I have A, I'm sorry, if I've got Y, I got Y and I've got Z, and if they set difference Y and Z, yeah, this slide is not correct. It's just going to give you what's in Y that's not in Z. So this row D4 is wrong. Okay. Left join. So I don't know if you guys are familiar with SQL. We're not really going to cover SQL in this course, but there's kind of this concept of left joins and right joins and inner joins and all sorts of stuff. But basically, with a left join, you give it two tables, and left join will give you everything that is in the left table, in this case songs, and we'll find matches in the right table. Okay, so left join says, I want everything from the left table, and then if possible, match things in the right table, and if you don't find anything that matches in the right table, return a missing value. Okay, so here, these are the 4 rows in the left table, and it says, okay, we're gonna match on John, so John plays guitar according to this, and so, you know, we get guitar, Paul plays the bass, and then we have no match for Buddy, so we get a missing there, okay? That's what we get. Same thing with left join, okay? You can join by multiple columns, that's fine. Inner join, you give it a left table and a right table. So the inner join is kind of like intersection in that it will only give you the results that have a complete match. Okay, so over here with the table on the left, we couldn't find a match for this row. Okay, and then as far as the table on the right goes, we couldn't, only these 2 rows, the information from these 2 rows are the only ones that get saved because these are the intersection here. So this information with George and the sitar and Ringo and the drums, that gets lost, and the information with Buddy and Peggy Sue, that gets lost on the inner join. Okay. The semi-join is even worse than the inner join. So the inner join will match it by this and return back the column plays. Semi-join will just kind of give you back, you give it the left, and it will only return the columns in the right table that match the ones on the left table, okay? So this is even like so it's kind of like inner join, but also for it's a left join on the column names, okay? And then anti-join is kind of like set difference, what's in here that's not in the other, and that's what we have there, okay? I hesitate to dwell too much on this because these are functions that are included in dplyr. So for completeness, we'll cover them here, but they're probably not things that we need to worry too much about as far as this class goes. If you get into SQL stuff later on in your career, then it's worth checking out inner joins and left and right joins and things of that nature. We'll wrap up here for today. Check out the blog entry that covers the differences between BaseR and dplyr, and then on Friday we'll cover regular expressions. Okay, so we'll see you in a couple days.